must have known who the talk was.
Good afternoon, and here we are again for our Wednesday afternoon seminar series. And I'm very pleased today to introduce a friend and colleague who has been associated with CERIAS and Purdue for a decade or more, and is really acknowledged as one of the leading lights in the area of cyber forensics and computer crime investigation. Professor Mark Rogers originally came to Purdue as a research scientist with CERIAS, and then moved over into the Department of Computer Information Technology in the College of Technology, where he's established one of the country's leading programs in computing forensics, a major laboratory that serves not only people locally, nationally, but around the world. And so it's with great pleasure I introduce our speaker today, Professor Mark Rogers.
Thanks, Beth. Welcome. A little bit of background. This was pretty much whipped together in the last 3 hours, so that's a little bit of a panicked email came out. Actually, this is a subset of a series of talks and discussions I've actually had with some of the intelligence community regarding this whole concept of the intersection between digital evidence, computer crime scenes, and intelligence. How do we connect the dots? How do we make sense of what we're seeing? How do we actually put what we refer to as meaning and context around raw data that becomes information that hopefully we're going to make some decisions about, which means that we need to turn that data somehow into knowledge. So we're going to call it basically dissecting digital data or context and meaning through analytics. And I tell you right now, we're not going to get a lot of math. This is going to be more of a conceptual approach to some of these issues and some possible solutions. And then I've got a couple of redacted case studies I'll talk about where the courts now, not necessarily the intelligence side of the house, which I obviously can't talk about some of their problems, but what the legal justice system is actually asking of the evidence as far as, well, that's great, but what does it really mean? What can we really answer with this? A little bit of my background. As Spath mentioned, I'm a professor over in CIT, a fellow of CERIAS, and I basically have been involved in the cyber forensics program here at Purdue since I got here, and I've been about 20 years in the field, ex-law enforcement officer from Canada, so you'll probably hear the odd A or a boot. A little bit of an agenda. We're talk about this concept of analysis versus analytics, the universe of data we're dealing with, connecting the dots, and what can this really tell us, looking at methods for connecting the dots, methods for actually looking at, we've got so much information now, how do we make sense of what it means, looking at points of view, and then I mentioned a couple of case studies, and I fully intend to have some time for some Q&A. So, primarily when we talk about digital evidence or digital crime scenes, the first thing that comes to mind is this whole concept of it's an investigative model. Okay, it's comes from the background of law enforcement. It comes from the background of something has occurred. It's kind of an analysis after the fact. If you're looking at it as far as a computer security model, it would be one of the, as far as the controls, it would be an investigative control. Something has happened. We need to investigate it. The common questions that are often asked in an investigative model are your W5s, right? Your who, what, when, where, how, and why. This is what the courts are interested in. This is what the evidence is interested in. This is what you see all the time on their CSI shows you see out there. These are the basic investigative questions that we're trying to answer. Well, if we step back, we can say, well, that's only part of the picture. There's the investigative information, but there's also science and there's a scientific method. The scientific method is really, you look at a theory development. Some theories develop from the body of literature that's out there. You develop some type of hypothesis. You test that hypothesis to determine whether it supports the theory, whether the theory has to be modified, whether the theory has to be evolved. And we look at things like probabilities. What's the probability that retaining the null hypothesis was correct? What's the probability that our prediction was correct? We have error rates, and we're really concerned with things like reliability, validity, and accuracy. And at first blush, it looks like, gee, that's quite a far off distance from an investigative model. You've got the scientific, you've got the investigative. This whole concept of analytics really falls in between that. How do we take things from the scientific and provide information back to the investigative? Analytics is really data-driven. We're talking about data mining. Here you're looking at, from the business world, you want to make decisions, right? You have a large body of data. Somehow you want to be able to make some type of a decision. That decision could be, who should we be marketing this to? Should the packaging be blue or red? Should we add that new widget? And it's based on statistical analysis, pattern identification, and data mining and some of the data warehousing techniques. Now, what's interesting is the business analytics component has been dealing with very large data sets for a long time. What's unique to the investigative world is we now have very large data sets. We have a lot of information. We've been very good at collecting data. We do a very good job of being able to collect data and clone hard drives and create images to the point where we have terabytes and sometimes petabytes of information to go through. What's not good about the investigative model is we still want to answer these questions, but how do we go through all this data to answer these questions? And this is where the analytics come in. As I mentioned, we do a very good job of collecting the data. The universe of data that we're dealing with comes from things like the small-scale digital devices, cell phones, right? PDAs, MP3 players. You name it, we all have some type of a device that, for lack of a better term, is really a smartphone, a small little computer, or some actual repository of digital evidence. We've got workstations, laptops, tablets, iPads, whatever you want to call it. We have this next version, which is basically where we in the digital forensics world have played with for a long time, and that is the traditional containers of the evidence. With the small-scale devices, you include things like your Xbox 360s, your PlayStations, your Wiis, your DVRs, your TiVos, all fall within there. You've got servers, network appliances, and sensors. You have embedded devices now. The ability to embed some type of a computing or some type of logic and logging functions and decision-making functions in things like cars. You've ever heard of the, I'm sure we're all familiar with the Toyota's recall. Okay, now they just recalled the Prius. Oh, it's not a problem with the mechanics. It's a problem with the software. It requires a software update. There are computer chips. There was an issue a while back with the pollution control systems. You could basically cause a car to fail and actually lock up while driving down the highway if a certain error code was actually presented within the vehicle itself. So these are what we call kind of these embedded, these devices that aren't traditional. Then we have what we're calling nowadays, I guess, the cloud, right? You've got things like Google, Google Docs, Google Mail. You've got these very large repositories, whether they're application servers, whether they're actual just storage devices out there on the internet capable of storing a lot of information. The end result of this, having this extremely large universe of data, is not necessarily can we collect it all, it's what do we do with it once we've collected it. It's okay to collect information, but if all we're doing is collecting it and collecting it and collecting it, and we're not doing anything with it, it's really not answering any questions. It's just collecting it. What we want to do in the digital forensics traditional world and in the intelligence community is to actually take that information, that raw data, and be able to make decisions on it. So we need to somehow be able to say what is important, what's not important, and what is completely meaningless because we can't figure out the importance of it. Yes?
So Mark, what's the role of privacy in all this collection? I mean, there's an interesting tension there. Is that going to fit into your talk at all, or can you address that?
Yeah, the issue with privacy is such a large issue, both in the intelligence world and in the forensics world. There's always this need to balance the need to investigate, the need to collect, with the need to basically maintain the constitutional rights and the assumed privacy that we have. The issue that we fall into with this content versus context is within the court system itself, context really can have an important part in whether Spath had a reasonable expectation of privacy on that data because of the context of where that data was in relation to the other data he had in his system. And